Compuware Strobe to save CPU. 4 real-life cases from the files of CPT Global. Before we begin today's presentation, there are a few housekeeping items that I'd like to address. To maximize the slide area, click on the full screen mode icon at the top right corner of the slide area. For an optimal viewing experience, please ensure that you have checked system requirements along with bandwidth considerations. If you have any technical difficulties, please click on the help link located via the question mark widget at the bottom left of your screen, where you will find details about system requirements and frequently asked questions. If you experience a blank screen during the webcast, please try refreshing your browser or pressing F5. To ask questions during today's presentation, please type your questions into the Q&A widget and hit submit. We'll answer as many questions as time allows. Also, notice the Learn More widget. Here, we've added a copy of today's slide presentation along with some additional content, including an insightful case study with CPT Global and Bank Postal, as well as a fact sheet on Compuware and CPT Global's partnership. We encourage everyone to fill out our survey before the end of today's presentation. By submitting your response, you will automatically be entered to win a $50 American Express gift card, as well as an opportunity to win the popular book, What on Earth is a Mainframe?, written by today's co-presenter, David Stevens. Also, if you like what you see, please share the webcast with others by easily clicking on any of the social icons in the Share This widget located on the left of the webcast console. We are extremely pleased to have as our speakers today Compuware Product Manager Spencer Hallman and CPT Global Senior Consultant David Stevens. Spencer is the Product Manager for Compuware Strobe and iStrobe performance tools. He has previously served as a subject matter expert for mainframe performance. He also has experience in programming on multiple platforms, providing tech support in addition to working in the operation research field. David has been working with ZOS systems since 1998 and consulting since 2009. David is also a lead system programmer at Longpella Expertise, and as previously mentioned, is the author of the popular book, What on Earth is a Mainframe? With that, I'd now like to welcome and hand things over to Spencer.
Thanks, Janet. Compuware is working hard to unify DevOps across the enterprise. DevOps is really a cultural shift that allows organizations to go faster with better quality. You may be embracing DevOps today, or another part of your organization may have already embraced it. Widely available tools from companies such as Atlassian, Jenkins, Zebia Labs, SonarSource, AppDynamics, and Dynatrace are helping your company execute a successful DevOps strategy. Compuware recognizes this and realized early on that in order for companies to go faster, that the mainframe must play a part in this. So we've done this by creating modernized interfaces and partnering with these companies, creating integrations for our tools through RESTful APIs and other means. Recently, we announced a global partnership with CPT Global, who I would say, unofficial mission has been exactly what DevOps is all about. They want your mainframe code to go faster and with better quality. So we've worked together for many years, and recently in November we announced a formal partnership. They're leveraging our tools, Compuware's best-of-breed tools, with their world-leading performance and tuning services. And with that, I'm going to hand it over to David.
Thanks, Spencer, and good day, everyone. Welcome to the webinar. Before I thought we'd start, probably the first question is, why on earth should we listen to David Stevens about Strobe? So let's cover that just briefly. I'm probably one of the better CPU reduction experts available worldwide, and one of those reasons is because it's a lot of what I do. Probably 70%, 80% of my mainframe consulting work that I do is CPU reduction, reducing MLC, saving money. It's an easy business case to make. So I've been doing that for a long time. In fact, I've done, I think the count at the moment is about 13 projects over the last 6 years. Some have been short, a couple of weeks. Some have been, some of them have been going for a couple of years. So a nice varied group of projects as well. Different countries, different industries, small, big. So it's a nice group. I've been using Compuware Strobe since 2009, and to be honest, both CPT and myself, we believe that a sampling tool like Compuware Strobe is essential for us to figure out how to reduce CPU. And I've been using it since 2009. Now, I'm not even going to pretend that I'm a Strobe expert. I'm more of a Strobe user. So this is actually going to be a bit of a different webinar. It's not going to be a webinar trying to explore all the different bits and pieces of Strobe. Really, it's just going to walk you through how CPT and myself have actually used Strobe in real-life cases to save CPU, and we'll actually be naming the figures and saying how much we actually saved using the actual tool. Now, I think I've already covered the using Strobe at different sites for different reasons. So, what are we going to do today? Today we're going to have a look at 4 real-life cases. They're all from CPT. 3 are personally done by me, and I've stolen one from another CPT consultant, because I wanted to show a bit of the breadth. I wanted to show the different things you can do with Strobe, some of the different features that can be used and how we use them in real life. So we can see some of the breadth of what you can do with Strobe to save CPU, but it's a sampler. It's not going to cover everything. It's not going to be a total step-by-step how to do it. It's just a feel of how Strobe has been used by us to save CPU. So let's get into it. Let's start with the first case code. This is a US-based financial services company, and we had a look at the COBOL code. So let's have a look at our target to start with. It's a batch program, COBOL VSAM. 3 major jobs, 1 program done by all of them. And as you can see, it's a bit of a monster. Certainly around 3, 4, 5 in the morning, it's consuming up to about 4,500 CPU seconds. So that's interesting straight away. Now, before we get to the results, let's have a look at how we set up Strobe. Setting up a Strobe for batch, I usually add a queued request. And the good news about queued requests is by default, they will Strobe and sample for an entire job step, which is really what I want to do. I want to have a look at the entire job step, not just a piece of it, so I can get an overview of the whole lot. And one of the big things I generally have to worry about is setting the duration and the number of samples. And this is one of those things that I've talked to a lot of people about, and a lot of people aren't really sure. And in many ways, I haven't really seen too much official stuff from Compuware about setting up the number of samples. But anyway, let's have a look at what I do and how I've actually figured it out. Now, Strobe is basically like a big camera that's taken lots of snapshots of the CPU. So it's taking a snapshot of what's actually executing on the CPU. Now, sometimes it sees nothing because the job might be doing I/O, might be waiting for its turn for CPU, might be doing other things, and it's not actually using the CPU. So Strobe can't give us anything. If the job or program is actually using CPU, Strobe can take a snapshot of it, and then it can start telling you information about what it was doing, why it was using the CPU, who was using it, and all that sort of good stuff. Now, you need enough CPU samples for an accurate picture. If you don't get enough, you really can't trust what Strobe gives you. Now, my rule of thumb is I want to have about 1,500 CPU samples before I really trust what Strobe gives me. But Compuware recommends 10,000, don't they, Spencer, which is a bit more than me.
Yeah, 10,000 is sort of the magic number because, as you mentioned, we're a sampler. There is a statistical error associated with our reports. So we know anytime we collect 10,000 samples that the statistical error is going to be around 1%, actually 0.98. So our goal is normally to try and collect 10,000 samples, but, similar to you, I'll take whatever I can get usually. And if I can get 1,500 samples, if that's all I can get, that's what I'll take. And, you just have to be aware of the margin of error in the report as you're analyzing it.
Yeah, but the flip side is you don't want too many samples. That's particularly relevant for me. If I go in, I set up a Strobe, and then my customer starts seeing their CPU costs skyrocket because I'm strobing, I'm not going to be particularly popular. So I've got to try and find a medium whereby we get enough CPU samples so we can trust and get a good idea of what's going on, but we don't start burning the CPU and dimming the lights of the data center.
Well, I mean, just to set the record straight, the overhead is particularly low. And when you do collect 10,000 samples, the overhead is somewhere between, 1 and 5 CPU seconds. And we do write that information to the sample data set. So we do have ways of figuring out how much CPU Strobe actually used. And we've actually taken a lot of the processing out of the measured address space and put it into the Strobe address spaces. So, you know, we're using sometimes even less than a CPU second to collect 10,000 samples.
I guess if it's all going into the Strobe address space, you can probably then measure it as well with something like a type 30. So you can get an idea of what your Strobe overhead is, can't you?
Or you can just go into SDSF and see how much CPU time the prototypes have used.
Indeed. Okay, so basically, how many samples? And this is the question. Now, I generally like to have about 1,000 to 1,500 samples a minute. When I first started using Strobe, I started using 1,000 samples a minute. And it wasn't any science. I actually asked one of the other CPT Global guys, and they said 1,000 samples a minute. I went with that, and that's actually kind of worked well for me. Since then, the processes are a bit faster, so I like to take a few more samples per minute just to make sure I get enough of what's going on. Now, that's assuming that we've got a good, 10, 15 minutes of sort of job duration. If it's less than a minute, you're not going to get enough samples, and then I start upping the samples per minute just to get that magic, anything between 1,500 and 10,000 CPU samples. And the way to do that is to set your session duration and your sample size. Now, what I tend to do with the session duration is I usually underestimate it. So in this example you're seeing, the job step was going to run for 40 minutes, so I told Strobe 30, just in case the job step this time runs a little bit faster than I expect. And then I do the 1,000 to 1,500 samples per minute, in this case 1,000, which gives me 30,000 CPU samples. So that's how you actually set how often Strobe samples and the frequency of it as well. Does that work for you as well, Spencer?
Yeah, and actually in the next 3 to 6 months, we're redesigning in iStrobe how the measurement request gets added. And one of the things that we're trying to do is put some intelligence in there that would go out and interrogate some of the SMF data that we collect to basically set that session duration for you automatically.
No worries. So one of the cool things about Strobe is it actually will tell you how many of these CPU samples it's taken. So you can then have a look at the end of the session and say, yeah, that worked, or maybe it didn't. In this example, we got 174,000, so I'm pretty happy with that. Now, Spencer, you reckon there's some smarts that Strobe's sort of like showing us here?
Yeah, so actually you can see that we took about 274,000 samples and we processed 174,000 samples. So actually when we started our measurement, our sampling rate was around 55 per second. And Strobe recognized that it actually was that the user had underestimated the session time. And so what it did was it halved its sampling rate. And what happens is that once it gets to double its target sample size, it will have its sampling rate and then continue to sample at that lower rate. And the next time it gets to double its recommended or it's what you have requested for samples, it will have its sampling rate again. So we recognize when you have really underestimated the session time, and we will lower the sampling rate to account for that.
Okay, so enough of actually setting it up. What did we actually find? Let's have a look at it. Looking at iStrobe, and it gives a lovely output, and straight away iStrobe tells us that it's a user program, the COBOL program. There's a few bars you can see on the graph, but if you have a look down, it'll tell you the offset. And the top two offsets are pretty close together, and actually you don't see it in the screen, but further down the third and even the fourth offset, they're actually all kind of in the same area within the program. So I call this a hotspot. And this, if I see a hotspot, a small area of the program that's consuming a lot of CPU, I start getting excited because I think, okay, this is actually interesting, and I reckon I can probably do something. But knowing that an area in the actual program is using a lot of CPU, that's not enough. You actually want to dig further and find out why.
That's pretty amazing there. I mean, that's like 500 CPU seconds if you add those two opportunities up. I mean, that's a god-awful amount of CPU time to be used at two small offsets in a program.
Actually, there's about 4 or 5, and we reckon it was about 65% of the total CPU time. If you remember that previous graph, they were monsters. We reckon 65% of it was just this little area, which for me is straight away, well, let's have a closer look. Now, I've never seen this documented, but what I tend to do with this sort of Strobe output is I want to get the assembler listing. Now, I use the list compiler option for Enterprise COBOL. It gives us the actual offsets, but also gives me the assembler breakdown. And as a assembler ZOS systems guy, that tells me exactly what's happening under the covers. Now I know a lot of other people I've talked to, they just have a look to see what the COBOL line is and try and work it from there. But for me, this is really interesting. So we can see the actual COBOL statements in blue. We can see the statement, also the module offsets in orange, and that's around about the area we're looking at. But have a look at the green. Now, if you're not an assembler programmer, it probably doesn't mean much. But what I'm seeing is I'm seeing a pack, a convert binary, an unpack, and they're expensive instructions. And what they do, put together, is generally they convert between EBCDIC and binary to EBCDIC. Now, if you're a COBOL programmer, you're probably starting to get a light bulb appearing above your head. But before I do that, Spencer made me put in this screen because he loves iStrobe, and he wanted to show everybody that iStrobe can actually sort of do a little bit of smarts as well.
Yeah, we can actually pull in the complete line of code there, so you can see in this example that, you know, we had another god-awful amount of CPU down to one line of code, and then, you know, iStrobe gives you kind of hints on what to do on how to reduce that CPU.
Now, this particular output, this isn't actually from our example. It's just a sample of what iStrobe can do. To be perfectly honest, at client sites, I rarely have access to this sort of functionality. Either they haven't installed it or I don't have access to it as a consultant. So I usually do my list option, and it still tells me a little bit more about the assembler output and everything like that, which is kind of nice. Anyway, let's get back to it. So, what is the solution? And those COBOL programmers that had that light bulb above their head, they probably figured it out straight away. It was the picture definitions. And this is one of those classic COBOL programming mistakes where you define a variable as a display when it should be a binary. Now, if it's a display and you're doing arithmetic, poor COBOL has to convert it between EBCDIC and binary, do that arithmetic and convert it back again. And certainly that WS worklen is a classic. It's just a length value, but they've defined it as a display, and it's just subtracting one, and it's doing all sorts of work. That WSLen found, it's a binary, but again, we're doing comparisons, and so again, it's having to do all those conversions between EBCDIC and binary, and that's just killing us. So the better definitions are, for that worklen, make it a binary, and for that len found guy, we just made it a character, because it's just doing a comparison, and that takes it out. Well, okay, well that sounds good. What was the results? What did we find? I love this graph, because this actually tells us straight away what happened. Now, this program had a little bit of different processing, so I took a kind of a month-end period before and a month-end period after, so you can see the difference in actual dates. But that tells the story, whereby we reckon we actually, in fact we measured using SMF30s, about a 65% reduction, which is a nice sexy 170 MIPS saving. So that was a really good result. So, let's have a look at a second one. It's Badger VSAM. Again, another multinational bank. We do a lot of work for banks and financial institutions. They seem to be most of our clients, actually, but we're happy to help them out. Another COBOL VSAM batch program. Several jobs all using the same program. And as you can see, it's a big CPU consumer. I put in MIPS rather than CPU seconds here, but as you can see, it peaks up to about 80, 90 MIPS. So it's certainly an interesting job to have a look at. Again, before we jump into it, Strobe Collectors. Now, what I've always done whenever I set up Strobe is I actually manually go into the Strobe Collector screen and I say, okay, and I manually set all the collectors I want. And in this particular example, I want the VSAM collector. And we'll find out why in another couple of sections. So Spencer is almost getting out of his chair. He is ready to say something. Go, Spencer.
So we're going to do a little bit of myth busting on this webinar. And the fact of the matter is that when Strobe recognizes that there's, CICS or DB2 activity or IMS or MQ series or VSAM or C's SVCs, it automatically invokes those data collectors for you automatically. There's only a couple of use cases where you actually need to come into this panel and turn on the data collectors, and those are generally for A2base, natural, and IDMS. So it's great that you showed this, but you didn't really need to come and set these options.
And I didn't know this until we actually started doing these warm-ups for his presentations, and Spencer started laughing at me. So there you go. And actually it's interesting, if you had to hit PF1 from that data collector screen, it'll actually tell you whether it was automatically switched on or not. So if you're not really sure, go to the data collector screen, hit PF1, and it'll tell you the good oil. So after we've actually sort of like had Spencer laughing at me, he's going to do it again. Because most of the time when I go into sites, I actually don't have access to iStrobe. So most of the time, I actually use the text-based reports. Now, when we started doing these warm-up sessions, Spencer looked at me, well, actually, we're on phones, so you could hear the cackling in the background. And Spencer, why don't you like text-based reports?
Well, in iStrobe, we actually can give you a lot more information than we can in the text-based report, just based on real estate and then, how you can, craft a report in iStrobe or web-based application. But just a little trivia there, you can see that, Strobe is spelled out for you there, spelled out in dollar signs to represent all the money that Strobe can save you.
Oh, nice one. So anyway, what you're going to see for the rest of the presentation is just basically we're going to be using the text-based reports, which is what I usually use, and certainly for these previous cases I do. But occasionally we're going to be giving iStrobe screens in because Spencer made me effectively, so he can actually tell you how better Strobe is as well. In fact, Compuware is you're kind of on a bit of a mission to try and convert CPT to iStrobe, aren't you?
We're actually on a mission to kill ISPF as a company, so we're going to take you along with us.
He keeps telling me, hey, we put this new thing into iStrobe, but it's not available in the text reports. Anyway, enough of the banter. Let's have a look at it. What do we actually find in the actual sort of like Strobe report, the text-based Strobe report? Well, you can see that the actual program down there looks like it's chewing up about 53%. So that's certainly interesting, and we could probably get the list compile option as we've done before. This example, what I'd like to do is actually to talk about the VSAM, because as a systems programmer, I'm actually usually get most of my CPU savings not by looking at application programs, but looking at the system issues and what's going on. And here, VSAM is quite high. In fact, it's about 31%, which is seriously high. Now,
yeah, in my experience, VSAM is usually 1 or 2%. It's usually a drop in the bucket. Even when you inefficiently buffer the VSAM files, you still don't see a lot of CPU to VSAM. This was an interesting one for me.
And this is kind of one of the things that we're lucky in CPT, because we're going to different sites. We can start comparing site to site, and we talk to each other as consultants, and we start almost get some rules of thumb of what is normal, what is a little bit high. And certainly 31% is pretty high, so that's certainly interesting for us. Now, the good news is Strobe, the text-based Strobe report, also gives us a lot more information about the VSAM. And this particular report you're seeing here, it tells us two really cool things. It tells us where in the application program is actually doing the VSAM calls, and it tells us the CPU usage for each of the offsets and which file it was getting to as well. We can see there that there are two big files which are, well, interesting, and certainly chewing up most of that VSAM CPU overhead that we saw. Strobe gives a few different VSAM reports thanks to that VSAM data collector, which apparently is now turned on automatically. It can tell you whether it's open for input or outputs, and these two examples, I only showed you the data component. They're VSAM within it, they're KSDSs, but I only showed you the data component here. They're open for input. They don't have a lot of records, but have a look at the number of reads. That's the stuff in blue. So not a lot of records, and the reads are just off the charts. Now, I can almost hear people starting to sort of say buffering, and it's a real popular area to actually have a look at, particularly when you see these sorts of statistics. Now, to be honest, I haven't had a lot of big CPU reductions from buffering. Reduction of elapsed time, absolutely. Some small CPU reductions, sure, but big ones like 30%, I have one or two examples, but really it's quite rare. But if the stats say buffering, we'll have a look at the buffers. And again, Strobe helps us out with here as well. Have a look at this. This is basically a report, and actually shows you for those two interesting files we've got a little bit more about what's happening. Now, you can tell it's using LSR, local shared resources, because the pool number is actually there. It tells us the number of buffers, and you could say, well, maybe they're a little bit low. Maybe we should increase the number of buffers in those. But look at the EXCPs. That's actually the IOs. That's your physical timers going at the disk, and they're basically nothing. Now, buffering only helps you to eliminate or avoid EXCPs, but here we've got nothing. So it's actually not a buffering problem. So I wonder what it is. What a lot of people don't realise, oh, that's right, Spencer, you maybe put this guy in, didn't you?
Yeah, go. So you're actually showing two different reports there. One was called the dataset characteristics, and the other was called the dataset characteristic supplement. And, you know, back when I was an FTS person, we would go out and print off these, you know, like 1-inch thick, you know, strobe profiles and go through them and put in little yellow stickies. But, you know, with iStrobe, it gives you all that information in one nice, easy-to-read screen. And so, you know, just by clicking the plus sign, you get that data set characteristic supplement data right there, as you can see on the report.
So, a lot of people sometimes forget, particularly when they're looking at VSAM and buffering, is that VSAM calls actually have to do a little bit of work. Now, usually that work is really not much compared to the I/O overhead of VSAM, but it still needs to get locks and do strings and its own internal processing and stuff like that. And here's an interesting example, is because that VSAM processing is actually consuming all of that CPU. So the solution, well, there's a couple of solutions. You could actually try and avoid the VSAM, and you could see that there wasn't a lot of records, so you could probably load those into memory and then actually try and do it that way. Particularly, I think one of the data sets was only sequential access, so that's a classic for maybe load it into a table in COBOL and just do the sequential access there. In this example, the customer had already put in logic to avoid VSAM calls, but it just needed some tweaking and tuning up. So we just basically re-looked at that code and actually improved it to avoid VSAM calls. And as you saw, I mean, there's not much records, a lot of VSAM calls, so by eliminating it, we actually sort of saved that CPU. What sort of savings? 20%, 10 to 50 MIPS, which is a nice savings, again, for some small programming changes. So let's have a look at the third one. Now, US-based financial services company, and it's a vendor product. Let's have a look at the target. A lot of people that I see when they use Strobe is they're really using it for their own programs. And the previous two examples were that. Own programs, you've got the source, and you can actually dig down into the lines and everything like that. I kind of use Strobe on everything because for me it's a bit of an X-ray, and it tells me what's going on under the covers, even for vendor products. So iStrobe, pretty much anything I can get my hands on if I think it's interesting. And in this particular case, it was a Connect Direct region. Now, I don't know how many people have strobed a Connect Direct region, but whenever I see it jumping up, it's just interesting to see what's going on. The VSAM reports we saw previously will tell us if Connect Direct's doing a lot of VSAM, and maybe buffering or something like that can help it. But I find Strobe is brilliant for finding out what's going on under the covers. So here you can see Connect Direct is a monster, particularly around about the 5 p.m. What's that? That's MIPS we're saying. It's getting up to 1,000 MIPS, so it's a monster. And I find that quite often with some of the actual bigger clients, and they're doing lots of file transfers with Connect Direct. It takes CPU. Let's stop, and again we're going to have a quick look. Started tasks. Connect Direct isn't a batch job, it's a started task. So usually you're adding an active request. Again, the good news is this is different from previous. With an active request, it'll only sample for the period that you specify. Now, I like to have at least 15 minutes, preferably 30 minutes of Strobe activity on a started task. That tells me what it's doing in the peak period, because I want to know what it's doing when it's really working hard, when we really want to save the CPU. So in this example, it was 4 o'clock or something like that when I actually did the Strobe. Number of samples, same rules as before for the batch job as well. And data collectors. I like to check the data collectors, and yes, Spencer's giggling over on the other side of the table there. I can hear him from there. But let's have a look about it anyway. Data collectors, here I'm interested in the SVC data collector. Now, Spencer, I think this is another one that's turned on automatically, isn't it? Absolutely.
It's a little more myth-busting. You don't need to do this. It could have saved you like 10 seconds of your life.
10 seconds of my life I'm never, ever going to get back. Over many, many times. It's probably a minute or two if you add it all together. So, yeah. But the SVC data collector is the one I'm really interested in here, and it tells me a lot about what the system's doing. What did we find here? Well, let's have a look at it. Now, you can see at the top, you've got the VSAM that we saw before. It's actually sort of like doing a lot of work. I think we dug into that, and I think there was a lot of the Connect Direct statistics. They actually had the statistics, and it was doing some VSAM work for that. And obviously, occasionally, it's transferring VSAM files. You're going to get the overhead for that. But for me, the second line, which we've highlighted as more interesting, is the Project Manager link. And that is like 16%. Now, that really should be something in the order of 0%. You shouldn't be loading it. And 16% indicates to me that Connect Direct is loading a program again and again and again and again and again. And it shouldn't. It's not a CICS. It's not something like that. It should just be loading and going. So this is interesting. The SVC report actually gives us some more detail, and it'll tell us which module and the offset is actually using the SVC, and it'll tell us the rough CPU time for each. So in this case, you can see there's two modules that are actually calling the link command to actually sort of load it in. What we found when we dug in is they had a statistics exit. Now, ConnectDirect is smart. When you define a statistics exit, it'll load it into memory once, and that's it. And then it will just call it again and again and again for every transfer. So it's doing it a lot. However, in this example, their statistics exit was doing a link to another module that was doing another link to another module. Or in other words, it was doing two program links for every single solitary ConnectDirect run, request, send, receive, anything like that. Solution, don't do it, basically. Now, Strobe here also gives us some information about which particular dataset name was happening. You can see the step lib, you can see it's BPAM, which is basically a petition load, and you can see the EXCP counts, which is pretty much off the charts. There's a lot of ways you can eliminate that. You could put the library into linked list, the library look-aside. You could maybe put the modules into LPA. Our recommendation was to merge them, just put all the modules into one, because one of the modules I think was just basically a link and not a whole lot of other processing. So we actually recommend eliminating that and getting rid of the actual area together. Now, I've given you 3 examples of how it could be fixed. We didn't remain in this client, so to be perfectly honest, I'm not sure what they did in there. I'm not sure which way they went. And certainly when we left, they were discussing amongst themselves which was the best way to do it. But assuming we're getting a 15% saving, that's going to be about 10 to 150 MIPS, which is, again, a nice save.
You know, vendor code is sort of an interesting area because people think because it's vendor code that you can't do anything, and I think he just demonstrated that there is something that could be done. And sometimes I've worked with customers where they've called me and they said, "Hey, I have a problem here. What do you think about this?" And I said, "It looks like a problem in a particular vendor's code." And we've actually set up conference calls with the vendor because the vendor ultimately wants to keep the customer happy. And I've worked with the customer and sort of acted as a go-between to better explain the Strobe information to the vendor. And oftentimes too in vendor products there's different settings. Some settings will use a lot more CPU, and they'll tell you, flat out, only use this under, certain conditions. So sometimes just going back and reading the manual will give you information about reducing CPU and vendor code.
Indeed, and we've had some similar experiences where we've actually had a look using Strobe and found some interesting things. You go to the vendor. We've actually had a good result just recently with a product. It was a DB2, so they're using the DB2 collector, but we found something, went to the vendor, they said, great idea, and they're putting out a fix to actually resolve it and cut down the CPU. So don't be afraid of vendor code. So let's have a look at our last case, a multinational bank, and it's CICS. Again, the target, now this is no surprise, have a look at CICS here. It's actually it's peaking up at around about 6,000, 6,500 MIPS when it's going through its peak period. And I see that a lot. And some of the big guys, CICS is your core transaction processor. It's going to be chewing a lot of CPU. So this is not a big surprise. And most people will actually use Strobe and they'll have a look at CICS. Now, again, yes, we're back to the Strobe Collectors, but this time Spencer's not going to be sort of like laughing quite so much. I'll go in here and I'll actually put a Y against the CICS data collector to collect the actual CICS statistics, which I don't think you have to do at this particular point, do you, Spencer?
Well, actually, CICS is another one of those. I wouldn't call it a special use case, but if you want to collect more information on specific transactions, you might want to visit the CICS data collector. And there's actually 2 different types of CICS profiles. There's what's called the CICS performance supplement, and then there's CICS transaction profiling. The default is to, if you don't visit this panel, is to do the CICS transaction profiling type of data. And if you want to get the CICS performance supplement, which would give you kind of the CPU percentages used by the transactions, show all the modules invoked by those transactions, you would say yes for a performance supplement. Transaction profiling, you can specify up to 5 unique transaction IDs or wildcard a transaction. And what we'll do is we'll break those transactions down and show you where the different APIs that are being called, and show you really how those transactions are performing from a service time perspective.
Yeah, so certainly for us, that performance supplement every time. Click Y so you can start breaking down the CPU by transaction and start going on from there. I think most people do that because what I find is most people, when they strobe CICS, they're interested in strobing CICS to look at their CICS programs to see what's consuming CPU and tune them up to reduce the CPU of the CICS programs. And after saying all that, I'm actually not using the CICS supplement this time. Again, as a ZOS systems guy, sometimes I'm more interested in just what the CICS region is doing as a started task. So forgetting it's CICS and just looking at it as a started task like we did in the previous example with Connect Direct. So having a look at here, and again, you can see all sorts of interesting bits and pieces, but for me, the interesting one in this particular example is LE, language environment, which is 3.5% of the entire region CPU. It's probably another one where going to different sites, you can get a feel of what's normal and what's not normal. And 3.5% for me, that's a little bit high. What have you found, Spencer? I
would agree, and I've even seen it higher. But, you know, if you think about that 3.5%, that's not just 3.5% during that measurement time. That's 3.5% that pretty much probably that region being up, you know, if it's up 24 hours a day, that's kind of a low hum that you're going to hear all day, and it's going to turn into a really loud hum. You know, it's money that's just going out the window.
And sometimes if we see something that's using a lot of CPU, we don't necessarily have to reduce it by 50% or 40% to get a nice CPU savings. And I've done things where it's reduced it by 1%, and it's been a nice result for the client as well.
And that's going to get spread across all those different CICS regions, assuming they're using the same, you know, LE options.
Every CICS region will be around about 3.
Yeah, so you think of all the CICS regions that you have, and then that becomes a big number really quickly.
Yeah. One thing I actually didn't mention, a lot of people are wondering what's the difference between the percent CPU solo and total. Always use the total. The solo time is where there's only one task consuming CPU with that module. But the total time is the total time we're interested in, and you'll see that we've been using that total time with all of the things in this example. So, the good news about Strobe is it actually breaks down that LE a little bit more, and so it tells us what particular areas in LE are consuming the CPU. And for here is get heap storage. Now, this is one of the ones I like to look at a lot, particularly if there's C code or Java code going there. Sometimes the LE heap overhead can be quite sizable, and it shouldn't be. There's ways of getting around it. And in particular, in this example, basically it was the LE parameters. But it's not just changing LE parameters randomly, it's doing it smart. So in this case, we actually use the LE report storage parameter for a short period of time. Actually, my boss, Brett Norris, actually reminded me, I should say. The report storage will produce a lot of output and will add a 1 to 2% of CPU overhead, something like that, to your region. So you don't want it on the whole time, but putting it on for a small period of time, it doesn't have to be too long, will give you an indication of what's happening to storage, and you can use that to tune your storage parameters.
I think it actually gives you recommendations of what you're supposed to set those values to, which is, I mean, nice job, IBM.
It's actually spectacular, and it's one of those really good things, and it can make a big difference. I mean, like I said, Java and C use storage completely differently to COBOL in many ways, and so these parameters can make a big difference. So we actually said, look, I won't go through what the parameters mean, though again, so like Spencer will talk about iStrobe. And iStrobe, when you look into it, you can actually click on these parameters and it'll give you some information and some recommendations. Also, the storage parameter is another one. Now, storage here, what you can see they're doing is actually got 0, none, 0, and that means that LE is going to overwrite any storage with zeros before the LE unit of work and after the LE unit of work. A little bit overhead. Unless you've got some real security reason to do it, I can't see why you do both. I can understand if you're doing it before because you don't trust your programs to initialize it themselves. I can understand that. After, unless you've got auditors that demand it, I'm not sure why. So certainly in this example, we recommend turning off that second one and not overriding it to zeros at the end of the actual LE unit of work.
So for you to get that data, you had to rerun the program, or I think it's RPT, OPT, to get those options. And actually, when you go and do a Strobe measurement, we collect that information in iStrobe. Of course, this is an iStrobe only. We actually pull the LE options and we do a quick analysis of them for you to show, you know, which LE options may be impacting your CPU. We also show you where those options are being loaded from. So, you know, if you think they were set to something different, you know, this is going to tell you actually where those LE options are coming from.
That's actually a nice little sort of thing. Otherwise, sort of like it can be a bit of toe tapping to actually sort of find the actual current options being used.
And again, clicking on those option names, like storage, it gives you an idea of it tells you exactly what that is.
And gives you some recommendations as well. So have a look at the storage one. It actually tells you in big bold letters, don't overwrite zeros at the end of the LE unit of work. So it's kind of handy. So, savings estimates. One of the things that I have to do as a consultant is not just come up with ideas, but I need to do a couple of things. Certainly with CPT Global, we don't just hand bits of paper over and get our money and run. We help our clients implement it, and then we measure the actual sort of like savings at the end to say, yes, it's been implemented correctly, and here is the actual savings we've got. So we're there for the actual sort of like the total cycle. We find that really handy because in some cases, if we just hand over a piece of paper, changes can get lost and not get implemented. So having us there working beside the client, it gives them a reason to put it in as we're reminding it, and then they can realise those savings earlier. But even before we do that, we need to convince the client to actually do the actual change, to actually implement what we recommended. And to do that, we really need to tell them how much we think it's going to save. It's not enough to say, change your LE options. The first thing they're going to say is, well, why? How much am I going to save? Strobe, again, is quite good because it'll give us an idea of what we can save. And have a look at this example here. LE overhead's 3.5%. Let's say we save 2%. The MIPS is about 15 to 100 MIPS from the type 30s. Applying 2% to the total CICS CPU usage, we're going to save between 15 to 100 MIPS depending on the time of day. And then we can go to the client and they can look at the savings and how difficult it is to put the change and then decide to go or not to go. So 15 to 100 MIPS, which is only a couple of percent of a lot of CPU, is a nice result. So let's just round up what we've actually talked about in the last 35 minutes or so. These have been 4 real-life cases. We're not here telling you what you should do. We're telling you what we've actually done in the field with real-life cases. We've actually given you 4. The first one was COBOL picture definitions. It was an example how using iStrobe and doing strobe setup for batch. Second one was showing the actual Strobe VSAM information and using that to save CPU and introducing it to the actual data collectors, and also to the text profile reports that Spencer doesn't like. Third one was actually saying, well, don't just look at your own code, go out and start strobing program products and find out what's happening under the covers from there. We also had a look at strobing a starter task and also a bit more about those Strobe collectors. And the last one was CICS, and we talked about strobing CICS, but we also talked about don't just strobe CICS and look at your transactions, but maybe have a look at the actual CICS running itself and look at what it's doing at the system side that can give you some ideas, maybe some parameters or some options that can change or other areas from there. But this is just a sampler, and I'm sure Spencer will come to your site and talk for hours and hours about all the cool things that Strobe can do and that weren't covered in this webinar. We didn't really look at the CICS transactions. We didn't look at IMS, DLI, ADABAS, DB2. I know the CPT Global DB2 guys love the actual DB2 reports coming out. It makes the job a whole lot easier. We didn't look at Strobe to reduce wait times or service times. So it was just a small sampler of what actually Strobe can do.
Yeah, I think we really just scratched the surface there.
I knew it would say that.
Somebody like me would love to come to your site and show you all the great things in Strobe and iStrobe.
And that's it, and a bit of marketing about CPT Global. So back to you, Spencer, for the roundup and the final bits and pieces.
Thanks, David. We are just a reminder that you're going to get a survey in a few seconds if you haven't already received it, and there will be a drawing to win a $50 American Express gift card, and in order to be in the running for that or to be picked for that, you have to fill out the survey. And as a special bonus, for this one webinar only, you will get a autographed, not just a copy, but an autographed copy of David's What on Earth is a Mainframe book. Which apparently is quite popular, I heard, at the beginning of this webinar. That's good. Yes. I think it's going to be rocketing up the Amazon chart. So with that, we're going to transition to the question and answers. Well, do you want to pick them, Spencer, or sort of like and start going through some of those guys? Some of the questions, yes. So first question is, what tools or data are you using to determine what you should be looking at when you start an engagement? I think that's for you. That's probably for me. It's a bit about how do we, what tools.
What we tend to do is we use whatever tools are available at the customer side. I mean, different customers have got different tools, different products, and so we generally fit in whatever the customer's got. I mean, we need CPU consumption data. So we need the actual SMF data, SMF type 30s, type 70s, for the ZOS type 1, 10s for CICS, 101s I think for the DB2 package accounting and trace if they're being collected. And we need some way of getting that information. We've got some tools that we can use ourselves that we can bring in to do it, or we can use whatever the client's got, SAS MXG, a TDSZ or whatever they got from there. Definitely lead a sampling tool like Strobe. That's definitely got to be done. And that's basically it. Apart from that, we'll use whatever's there. I mean, I use RMF, or if it's a BMC shop, it's a CMF. We might use a Megamons or the main views if they're there. And basically the existing tools are there. So apart from that, there's not a lot else that we need. We've got a few little utilities or batch things that we can bring in if we need to do something. Pretty much it's whatever the customer's got. But certainly SMF we need, and we need a sampling tool like Strobe.
So we have another question kind of along these areas, but how do you convert that type 30 data to MIPS? Or how are you calculating your MIPS?
I actually use the IBM LSPR, and I can't remember the exact format. Basically, I get the LSPR, I have a look at the actual MIPS rating. They don't call it MIPS, they actually call it something else, but I'll get their MIPS rating. I'll convert that to a CPU seconds, because it'll be different by dividing the MIPS rating by the number of CPs for the model, and then actually sort of do it from there. So I'm using basically the IBM LSPR. I know some of the actual other CPT Global consultants, they like using Cheryl's table or what she's got there to actually do that conversion as well. But I think they're basically pretty much the same thing.
Okay, we got another question. I often see that .common or .commonX as the module consuming CPU. What does that mean?
That's probably one for me, isn't it?
Well, I can answer part of that too, but go ahead. You're the expert.
How I do it. Again, we'll tell you how I do it, and then Spencer can laugh and tell you how Compuware tell you to do it. Basically, Strobe is actually smart, and what it'll do, it'll look at an offset or an area of memory which is in the process status word. So it's saying, okay, this particular area is consuming the CPU, and it'll go and try and look up which load module that is. Now, most programs, I use a load or link macro to load something into memory, and then Strobe can go and have a look at that and map that to a module. But you don't have to do that. Occasionally, you'll find some monitors, and particularly do it, they'll actually load it, and then they'll copy the module up to common or another area, and then they'll branch to it. Now, Strobe doesn't know that, so he can't tell you what's happening. So it just says, look, there's something in the common area that's not actually in the loaded programs area that's actually burning the CPU. So for me, in that case, I've actually got to get a dump of the address space, go to the actual address, and look for iCatch. And usually you'll find iCatches in there about this is this particular product, this vendor, and sometimes it'll even give you the actual date it was compiled and the version number and stuff like that. So that's generally how I do it. Is that the Compuware way?
Pretty close. But let's move on to another question. How would Strobe help identify issues with a BMP? And I assume they mean like an IMS BMP.
Probably asking the wrong person. I'm not the IMS expert. Usually I just run Strobe against a BMP, and again I'm kind of looking more for the ZOS stuff. Particularly BMPs, I'm looking for program loads which indicate that maybe that preload list isn't great. Or maybe LE options again, but there's something else.
So I think I can handle this one. With a BMP, you're issuing a bunch of DLI calls, and what iStrobe's going to do, or Strobe's going to do, is it's going to identify those DLI calls for you and show you how much CPU they're used. So as a developer, you'll see which DLI call is your most expensive, and you'll hopefully be able to address that. The other thing that we actually, an enhancement we just came out with in version 16 was we will show you the IMS preload report as well as modules that may not be on that preload report and if there's activity to them. So helping you optimize the IMS preload report.
That's smart, because normally without that I'd have to do a GTF trace.
That's what,
go back and find out what's in the preload list.
Yeah, that's what actually one of the users who requested this, he was explaining exactly what he did, and he said, if you can do this for me, I will love you guys.
That's actually pretty spectacular. It's great. Yeah. But is that in now, or is it coming in?
It's in the product today, yes.
Okay.
Version 16, to be precise. Do you have an average dollar cost per CPU second? I know each shop is different, but sometimes we were asked by management how much CPU we saved.
It varies dramatically, and it's one of the things I'm not allowed to actually tell because everybody's got non-disclosure agreements and everybody pays a different amount, and it depends what you're doing. Are you using MLC? Are you outsourced? It can vary dramatically, so the answer is, I'm sorry, no, it can vary a lot.
Okay, I've heard that Strobe cannot report on SRB or zip processing, only TCB processing. Is that correct? I think I can handle that one. It's true today that when we're sampling, we don't see the SRBs executing, but there's one unique case that we do capture the zip processing for DB2 SQL statements. But we're actually working on an enhancement today that we hope to deliver in April that you'll be able to see the SRB activity. So we're actually looking for customers now to be part of our pre-GA program. So if you're interested in seeing this important data, and helping us influence how the reports get created, please contact your Compuware representative. But we will actually have support in both the text-based profile and the iStrobe profile to show you that SRB activity. And I know every time I visit, your management, Jerry, who is your CEO, that's the first thing he always asks me. He's like, when are we going to get that? Well, Jerry, if you're on the phone, you're going to be getting it very soon.
It'll make me very happy, I'm sure.
Yes. So I think that's the end. We weren't able to get to all the questions, but we will contact you directly. We'll send you an email with the answer to your question if we weren't able to get to it today. And the presentation, I believe, is available. I think that's one of the questions there. So somebody's looking for a reveal of the COBOL PIC definition, so you'll see that in the download of the presentation. But at this point, I'll throw it back to Janet.
Thanks, Spencer. Thanks, David, for a great presentation. As Spencer mentioned, those questions that we didn't get to, we will follow up directly, and a replay of the presentation will be sent out to you within the next day or two. Thanks for attending today's webcast, and have a wonderful day.